Hello everyone, this is a video lecture for College Algebra, Math 1414, Section 9.4. We are now going to talk about matrix inverses, or inverse matrices, or something like that, inverses. So whenever I say inverses, I'm thinking back to my f of x and f inverse of x. Well, now we're going to have A and A inverse. Just a little negative one up there. Some properties. A times A inverse is equal to I, and I stands for identity, which in our case is a 1 0 0 1, or a 1 0 0 0 1 0 0 0 1, or any of these. They're all the same. Basically, it's kind of indicating a 1. And so just as you understand what inverses are, let's just say I had a 2 times a half. Isn't that equal to 1? How did I make that into an inverse? Well, basically, 1/2 is 2 to the negative 1, isn't it? See how they cancel? And that's the idea with inverses. Okay. A lot of times I do the first question on the homework. I think that I skipped it. Yes. Now, it might maybe been a little bit since I actually did the homework. Maybe they rearranged it a little bit. But traditionally, the very first question on the homework was hard. And then the second question on the homework was super easy. So I would rather first show you the second question on the homework. Very much opposed to this normally, okay? This is your second question on the homework, I think. Pretty sure. And then we'll come back and do the first one here in just a second. Okay. So 9, 4, 5. They have an A matrix that is 5, -6, a 1, -2, and then I have a B matrix that is 1/2, -3/2, 1/4, -5/4. By the way, I don't know if you ever noticed, sometimes I do this, sometimes I do this. It doesn't matter. They're both the same. I think I just do one for size and space. Like I didn't have a lot of space, so I just put it right there. I don't know. Just a thought there. And so what they're wanting to do is find A times B. And then they want to find B times A. And then they're saying, are those inverses? And you're going to say yes or no. Just as always, we're going to use our trusty Desmos. And so I got A. Let's do it again. My A is going to be a 2 by 2. So I got a 5, -6, 1, -2. I got a B, which is going to be a 1/2, -3/2, 1/4, -5/4. A times B. Notice I got the identity matrix, 1 0 0 1. What about B times A? Hey, look, I got the identity matrix. They cancel one another. And so if they want to know what this is, you're going to create a matrix like you did in 9.3. It's been a while since that. And you're going to put these in as your answers. And then they're going to say, are these inverses? You're going to say yes. Because we just talked about that. If you multiply them and you get the identity, yes, they are inverses of one another. Awesome. I think there's another point here. I think it says like B is equal to A inverse. That might be the way they express this bottom one, this yes. Regardless, you're just looking for the 1 0 0 1. If you get that, they're inverses. Okay, now for the first question on your homework. 9, 4, 3. Again, this might have been rearranged since the last time I looked. I'm just going off my notes here. -2, 3, -2, 4. Okay. And they want the same thing. They say find A times B, find B times A times A, and then are they inverses? Let's do some math. So I need to put in my A and B, just like last time. -3, 0, 2, negative 2. New matrix. Put in my B. A times B. Uh-oh. Uh-oh. Those are not the identity matrix. Those are not 1, 0, 0, 1. I don't care what they are, but they're not inverses. Inverses? No. Yeah, the problem is that you still actually have to find what these are, and you have to go put them in. Now, this isn't too bad because we got Desmos now. Back in the day, it was a little bit more difficult to do all this. But that is okay. We got it. Cool. All right. That was pretty simple. Next one. So 9,4,17. They say that they got this formula. Capital A is equal to little a, little b, little c, little d. My inverse of A is equal to 1 over AD minus BC times D, negative B, negative C, and then an A. And then they give me what my actual A matrix is, 6, negative 3, negative 2, 1. And they say, go ahead and find A inverse now, using the formula. You must be kidding me. Exactly, I'm kidding you. I actually have it written here in my notes that says, ignore that formula. We will be using a calculator. Let me show you. We're going back to Desmos. And I'm going to put in my A matrix that they gave me. 6, negative 3, negative 2, and a 1. So how do I find my A inverse? I do A. And then, oh, you can see it right there, a little A inverse. I'm going to do power negative 1. Oh, doesn't accept it? Well, that's just silly. Yeah. That's the answer, by the way. It doesn't work. I just don't like when it happens on the very first try. Anyways, you could just click right here. Oh, you guess you can't click right there. A negative 1? Okay, there we go. Okay. Regardless, put in a little power negative 1 and it's not going to work. Oh, man. And so, what do you even put here for this answer? You put, it doesn't work. It doesn't work. No inverse possible. And that happens sometimes. I'm just telling you, sometimes this happens. Look, right here. You didn't do anything wrong. It just doesn't work. Now, I'm sorry that just happened on the very first time we were going to do it. I'm just going to do my own for a minute. Is that okay? Because I want to redeem this problem. And you might have one that works. Who knows? New matrix. 1, 2, 3, 4. Super imaginative today. A to the power negative 1. Boom. And you can see that we get our answer immediately. Our inverse is just by putting A to the power negative 1. That's all you have to do to find your inverse. If it doesn't work, it doesn't work. If it does, you got numbers. That's it. I actually have on my notes here that this no inverse possible. It says, this was a terrible first choice. Well, I guess that happened on question number 1 on the homework as well, didn't it? So in this section, twice now I have been seeing where they give you a bad answer up front. And it's not, to me, it doesn't lead to intuitive grasping of the concepts. But that's just me. So just watch out. Okay, watch out. Some questions are like this, and some questions are like this. And you got to be prepared for either one. Let's keep going. So the next one has this really cool formula at the top. So A, augment I, RREF, I, augment A inverse. Now, this is the coolest thing ever. Love that formula. And, yeah, we're not going to do it. So, they want to find the inverse to this matrix. They say use that formula to blah, 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 blah. No. Instead, I'm just going to do my A inverse here. No, I mean, I like that formula. It is a super cool formula. I'd love to have the time to be able to talk about it, but it's not really going to happen. So you put this in, you get an answer. There's your answer, and you're done. Like, that's it. Here, I'll just write it down so that everyone's happy. Look, you actually get real whole numbers sometimes. You don't always have to get fractions. You don't always have to get things that say no answer. You get real answers sometimes. It's okay. 9, 4, 31. So this one's a confusing looking problem, but ultimately not bad. Oops. Let me write all these z's and x's and y's and stuff down. Okay. Negative 4x. That's a 4. I had somebody comment about my 4s the other day. Like, hey, is that a 4? I said, yeah. Nobody says anything about my z's. My z's are really cool. So, yeah, they got a slash through them. Ha ha. The reason why, by the way, is because, and look, hey, just let's talk about it since I brought it up. As you keep going on the math classes, you're going to have a lot of 2s and you're going to have a lot of z's. The only thing that's different between them, at least for me, is a line through it. I got so many problems wrong by just saying 2 and z, and yeah, it ain't going to work. Put a little slashy sign through it. I know some people do 7s like that, but that's up to you as well. Okay. This problem in particular has a box, and then it has an X, Y, and a Z, and then it has another box, and it's very confusing about what they're wanting. Actually, all they want is for you to put this stuff in here and this stuff in there, and, well, that's it. This is a 3x3 matrix, and this is a 3x1 matrix, and, well, that's actually all I got. That's it. Yeah, there's nothing else. So, cool problem here, because that's what we're doing. I can't remember if there's anything else in particular that you have to do. I know that there is theoretically stuff that we should be doing with this. I just can't remember why I didn't put anything else. So, those are your 2 answers. If they ask for, like, results, they say, hey, find X, Y, and Z, and stuff like that. Let's just say, they say find X, Y, and Z, and they give you the 3 boxes. What are you going to do? What are you going to do? You're going to look at this guy right here, and you're going to RREF it. They might give you some kind of weird formulas. Oh, use, hold on, it's X is equal to BA inverse or something like that. Gosh, what is that formula? I didn't even write that thing down. That's why I don't use it. A inverse B. I think that's it. That's the formula. No. RREF. It's cool. I like it. I like formulas just as much as anybody else. But we actually got to pass our classes and pass the tests and quizzes. So we're just going to make sure that we're good on Desmos, because that's allowed for this final exam. Here's another one, kind of similar. Okay. They want the separate equations. And so you need to rewrite them. This is an X, Y, and a Z. Obviously, if you multiplied this would come in down and across. There's your number, equal sign, augment, da-da-da-da-da. So then I got negative 3x minus 8y. Oh, man. I didn't want to zoom in. Hold on. Okay. And then I got what, like plus 0z is equal to 3. Now, hold on. A section or two ago, I was trying the Z, and I think it worked. But here, it will not work for you. Do not include the 0Z. I have a note saying, do not put it in there, because it's not going to work. Something about not being simplified. So just watch out for that kind of stuff. I got a 1x. Ooh, don't even put a 1. That's not simplified. X plus 7y plus 5z is equal to negative 6. And the last equation is an 8x plus 6y plus 4z is equal to negative 1. There's my equations. If they wanted you to solve for x, y, and z, what would you do? You would convert this into a matrix. You would RREF it. 9, 4, 7, 1. I got x minus 3y plus 5z is equal to negative 14. I got 4x plus 2y plus 2z is equal to 12. And then finally I got 5x minus 2y plus 5z is equal to 3. And again, with these boxes, box, xyz equals a box, we just did this. We just did this. This is not hard, but it's like, grrr. Again, I believe you have to type in the matrix size. You have to like click the matrix button, pop it up, and start typing it in. A 3x3, a 3x1, all that kind of stuff. Again, not hard. Not hard, okay? What they do want you to do for sure here is solve. And so I'm going to rewrite this as a matrix instead. Because, well, I'm going to. It makes it much easier. I'm going to RREF. I keep on zooming in. No, don't zoom in. I'm going to RREF this guy, and we're going to get an answer. So here we go. New matrix, 3 by 4. I got 1, negative 3, 5, negative 14, so on, and so forth. RREF. Oh, look, we got answers. Like just easy answers. Look, notice the 100010001 pattern. Therefore, your answers are just 4, 1, and negative 3. There you go. So we got x, y, and z. And so we got 4, 1, negative 3. Cool. I have one last question. And this one's kind of different. And so we got to talk about it for a minute because it's different. I like different problems here so we can know what to do on these different problems. 9, 4, 51. There's a part A and a part B, and I think that there's another one just like this, but we're going to be encoding and decoding matrices and doing letters and words and stuff like that. So, for part A, they say that we have A is equal to negative 5, 1, negative 5, 2. So that's your matrix. And they want you to encode a 4-letter word, and this time it is love. Oh, so nice. So first off, we need to find out the numerics for each letter as I go through the alphabet. A is equal to 1, B is equal to 2, C is equal to 3, and all the way down. So I'm going to give you L is equal to 12, O is equal to 15, V is equal to 22, and E is equal to 5. Okay, so we have that. What we're going to do now is say A times this M. They actually call this one an M. And we're going to be getting another matrix, which is E, which is that encodedness that they're talking about. As I write this down, I want to just tell you that we're very picky about this going down. It has to be going down. At least as far as I remember. I remember one time I did it across and it just did not work at all. And so they like this going down like this. I'm going to multiply this and let's get an answer right quick. Let me multiply those guys. Oh, yeah. I probably went too fast. What do I mean by going down? Notice that I'm not reading across, I'm going down. I got the 12, 15, 12, 15, 22, 5, 22, 5. Notice I'm going down, not across. That's what I mean. Okay, so new matrix, and we're going to put our A matrix in first. That's going to be A, negative 5, 1, negative 5, 2. And then we got our B matrix. The next one is going to be a 12, 22, 15, 5 going across. A times B. And you can see we got negatives and all kind of stuff. Again, reading down, we got negative 45, negative 30, negative 105, negative 100. Let me write that down. That way we're okay with this pattern. I don't want one of you to make a mistake about down or across or something weird. I don't know. Maybe the across will work. I haven't tried it in a while, but I just remember the down working every time. So down it is today. And so I'm going to write out my encoded message here as numbers. That was supposed to be a nice little box. Part A, answer. Here you go. Negative 45, comma, negative 30, comma, negative 105, comma, negative 100. So what does it mean by encoding, decoding? Basically, you're trying to send encrypted messages across the internet, let's say. And so you're trying to spell out love, and you want only the receiver to be able to pick that up. You don't want anybody else to know. This is a perfect way to pass love notes in class, right? So then you send them this list of numbers, and they're not answers to an exam. Rather, they're just the word love. And the only way that the person can actually see all that is if they likewise have this encoding matrix thing. So if both of the people have that same matrix, they can both encode and decode what's going on. So part B, it's on the reverse end now. So let's just say you sent a nice love letter to somebody, and you folded it up in a paper airplane and threw it across the room, and they caught it. Oh, wow, so nice. And it's just numbers. And they go and do the math, and they go, ha, 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 ha. And then they go and write their own message in paper airplane back to you. Now, you're going to have to decode whatever they sent you, and so you're going to have to use the inverse in order to do it. And they're saying now decode, and here's the message that came back to you. It was negative 26, negative 17, negative 105, and negative 100. So I don't know what those mean. I mean, you could probably guess on some of them, but honestly, we have to just do the math. And so how this works, of course, is that I'm going to be multiplying this matrix here by these numbers. And I am going down. I'm going down with this. Going down. And so I'm multiplying these two matrices together. Guess where? In Desmos. New matrix. And so I got negative 2/5. I would do a little bit more about this inverse stuff because you don't have to do it the way I'm doing it right now. I'm just being as plain as possible. Okay? I'm not trying to be fancy. I'm not trying to show any kind of tricks. I'm just going to do it. Okay? So I'm just doing it as they say. But the trick is that you didn't have to retype A because you could have just used the inverse button, this guy, and it would have worked just fine. But let's not go there. It's not a big deal. A times B, and I get my number here, okay? So let me go ahead and list out those numbers that I got. So I got 7, 9, 22, 5. Remember that we're going down here. And so I got a 7, 9, 22, 5. And so what letters are those? They are a G, an I, a V, and an E. Nice. So that's the receiving end of the... So you sent a love letter, and they sent you something like give. Give what? I don't know. Maybe only you two know what that means. So, I'm done. Done with matrices. We're going to move on to the next chapter here in a few minutes. So thank you very much, and have a great day.